Hello everyone, welcome to my presentation. As you can see, I will present my implementation of the research paper Stock Market Prediction using ensemble of graph theory, machine learning and deep learning models. And this is Said Ahmed from Toronto, Canada. So what is the problem? The problem is to predict the stock price correctly, right? So there are opinions whether we can or we cannot predict stock prices correctly and or consistently. However, with the advancement of technologies and with the data availability, nowadays the chances to be able to correctly predict prices has increased. Now, when we predict prices, what we do? Usually, we select some stocks and that some interval and we predict price for that particular interval. And we use statistics and machine learning in general, right? This paper has went beyond that and utilized the spatial and temporal relationships among the stocks and utilized that for prediction. And to understand the spatial relationships among stocks, the price interactions and correlations are mapped into graph, and that graph is used for the prediction along with the historical prices. The related work in this domain involve statistical models like ARIMA, Walt Winters, or machine learning, deep learning, LSTM, SVM, Bayesian. SVM, LSTM, they work well. Now, this paper, what it has done, as I told before, the stock interactions and correlations, they mapped into a graph, as you can see from my implementation as well. And then you can see the architecture of this paper. They use graphical convolution neural network and CNN, multiple blocks of this, and then eventually a multi-layer perceptron for the prediction. And they deliver this graph into this model and also the time. Yeah, I did the same thing. Architecture will vary a little bit, but in general, I build the graph and then put it right. So in implementation, the steps that I follow. Presentation will also follow this. So it's very similar to the traditional or overall data analytics or machine learning project development. First, the data, right? I used financial stock prices data from Yahoo Finance. I scrapped it, and also the some financial news, Yahoo Financial News stored in Kaggle. I actually tried one another data set from Kaggle that has data from 1975 to 2022 or something. So there are some different challenges to align. Eventually, I could make it work, but I think to align with the paper, I selected the 30 stocks that the paper is using and from Yahoo Finance. And after data, we try to understand the data. That's what I also did, understand the data and suitability and data exploration, and then treatment for missing values and null values. I think a couple of missing values I used interpolation to for those. And actually, Yahoo Finance did not have two stock data, so those missing values, I just removed this from the data set. I worked with the 28 stocks instead of 30. Now, afterward, we do feature selection and feature engineering. In feature selection and feature engineering, when I used Yahoo, I just selected the corresponding data that I need, date and the stock ticker and the closing price. Sometimes adjusted closing price can be good, and then I could grab other features, but I did not go for it, right? And the other data set, yes, it already had many different features. I just kept the required ones. And feature engineering, I believe the graph generation, you can say, sort of feature engineering. Anyway, so yeah, graph generation, the next step, the graph generation, right? So I built graphs depending on the prices, correlations of these prices in different stocks, as several different graphs, Pearson, Spearman, Candle, and Financial news based. Okay. One another data set was financial news from Yahoo News. Okay. So afterward, I built some models. I used multiple different models. I tried to go as close as possible. I think the closest one was GCN, MLP, and GCN, CNN, MLP. That was very close, but the paper has used multiple blocks. In my case, I used only one block. Now I tried other architectures like GCN and MLP, and another thing is deep graph CNN, another architecture. GCN plus LSTM plus the raw equations, those are something, but I did not go that far. And after I fed my data into this model, I get some predicted prices, and then I utilized, I conducted some experiments, just I think by different varying some parameters, hyperparameters, and the platform variations to get some results and see what sort of result I get. And eventually I use some performance metrics like RMSE, MAPE, and mean absolute error to show the performance in terms of how closely I could predict the prices. Now, as I told, data set is Fortune 500 company out of 30, and news, it has greater than 15,000 news. The paper had 1 million, mine is 15,000. Also, I also told that I used another data set, but eventually I moved away from it and utilized this Yahoo 30 company data set. Now, these are the graphs that I built. So, Pearson correlation based. If the correlation is greater than 0.5, then there is an edge between two stocks relations. For Spearman, if it is greater than 0.4, for candle, if it is greater than 0.3. And financial news, if the stocks are mentioned in the same article, we create some edge and then put it weight 1. If two stocks are mentioned in 20 different articles, then we get 20 weight for that particular edge, right? I did not show the edge weight, but yeah, weight is there. Financial news is the last one. Okay. So the models and platforms, as I told, I used multiple models. One thing is GCN plus MLP. Another was GCN plus CNN plus MLP. This is the closest one. And the paper is multiple blocks. This is the deep graph CNN. You can see there are lots of many GCN and then short poly 1D convolution and neural network. It is similarity to the paper as well. Probably if we could do multiple blocks, that probably could get more similar to the paper. So these are the 3 different architecture that I used, and GCN LSTM was one another under considerations, and the raw equations for the GCN and CNN on the same data, and then do it in a sequence so that multiple blocks are working on the data for the prediction. That was another. However, only these 3 are implemented. And in terms of platforms, you can see Analytic network is stellar graph. There is the graph mining library, and Analytic, I think, financial news based, and it is there. While finance based data is graphing. Now, so I have the graph, I have the model, then I fed the data into this model, and using some experimental parameter configurations, I tried to see how it performs. And one of the experimental case was for the GCN plus MLP and 1000 epochs. I used a dropout 0.5, and yeah, epoch is 1000. Usually learning rate 0.1, that's what I use for this. This is the performance that I get. And then you can see, so validation sometimes follows training, and sometimes our performance it comes closer, right? And this is the Pearson Spearman, and then Kendall and the news best. And this is the performance you can see. So this is the 1000 epochs. This is the 10,000 epochs for the GCN plus MLP. If I see that here the news performed the best, and then I will say Kendall, then it's Pearson and the Spearman. The paper, I think news was first, like us. Kendall was second, like us. But in the paper, then came the Spearman, then Pearson. But in my case, Pearson and Spearman got interchanged, right? That's what happened. And for 10K epochs, I can say Spearman is the highest. And I can say news and then candle and then the Pearson, right? So there are some little variations. So I will take that, okay, this probably is closely matching with the paper. So the paper outcome is valid. We can say. Another thing is it is giving varying results. So we probably need to do some more experiment and see where we get the stable and the lowest MSC. That's what we can conclude. Now this is the second case, GCN plus CNN plus MLP. GCN plus CNN plus MLP. And I used, it is the second architecture, right? 1000 epochs. And you can see there are two blocks of plotting. One is here, and another is here. The reason I did it two, looks like for the 1000 epochs, I actually get two different sets of output alternatively or something like this. So probably it's not getting stable, and I probably need more epochs or probably some parameter adjustment to get a stable result. Anyway, I may take the second one because it might more closely related to the paper. So this is the one. So you can see still news probably is the best, then probably the candle or probably Spearman and then candle and then Pearson. It's more close there, and you can see this validation and training following part. And now 10,000 epochs for the second architecture, GCN plus CNN, plus for 1000, and this is for 10,000, right? 10,000 you can see news, and then probably Pearson, then candle, and then sorry, news, and then Spearman, then candle, then Pearson, and you can see the corresponding numbers here, and you can see that graph there, 10,000 epochs. So in my case, it looks like I'm getting more news and then Spearman, candle sometimes coming, but I think sometimes Pearson is also there. Okay, so in the third case, it's the deep graph CNN. Okay, as I told, I will not say that this is outcome is correct or this is reliable outcome. So, however, it was something interesting to try because it needs many different training graph, many different testing graph, and many different validation graph. In my case, I just had one graph, right? So I divided it into training, testing, and validation. If we read it to the art, I got some output, but I think because I didn't have many, it closely matched the loss MAC to just very close. I think there was another challenge. Another challenge was, I think, the target variable, setting the target for this deep graph. I could do a little better. So that is one other challenge to fix. And I believe I could do something little bit more. I could make more training graph using open price, adjusted post price, that probably per minute, or probably divide the time series data into multiple chunks and then create some training graph. I believe this will be something interesting to see using graph and many different training graph, testing graph, and see whether it can predict or not correctly. Okay, so yeah. Now I will do some more comparison with my work and the paper. So in terms of architecture, as I told, this is the closest architecture for me to the paper, and this was much simpler one. And deep graph CNN, it is something a little bit different that I write. These are something seems promising, promising and work well. However, I didn't go that far. Now, in terms of architectural challenges, let's say, so they use multiple blocks. I give some try, but it probably need more work. I think there are some couple of challenges. I think in the paper, they mentioned that they combine some GCN and CNN output and feed to the next. So how does combination and how does the output looks like? That probably I need to explore more than I could probably do it. Or another option could be graph data goes to the GCNB next layer and the CNN data outcome goes to that could be something else. So another thing is modifying those data to adapt to the next level. That is another challenge. I gave some efforts in both areas, but eventually things did not align well. So anyway, and for deep graph CNN, as I told, I could use multiple training and testing graphs that could help. And let's see how those numbers look like. So this is for 1000 epochs, GCN plus MLP architecture, GCN plus CNN MLP architecture, deep graph CNN. I can ignore deep graph CNN for now, right? This is the paper. You can see my numbers slightly couple of times, but still it needs fine tuning to get the more closer correct numbers. But among them, I can see in terms of RMSC, this is the order: news, scandal, Pearson, news, scandal, Pearson. For MAP, news, Spearman, news, Spearman, but multiple different architectures. So MAE, news, scandal, Pearson, news, scandal, Pearson. Overall, we can see, I think the circle is the first lowest. So we can see that GCN plus MLP still it perform good, right? Very close to GCN plus CNN plus MLP. Still, this one is more closer to the architecture, but it is simpler, but still it performed very close. Very close means I mean even better, right? So what happens with the higher epochs? My in general perception was GCN, CNN, MLP. This architecture performs better with higher epochs. I think the numbers usually come lower. You can see these numbers are comparatively higher than these numbers. Now here we can see in terms of RMSC, we can see news, GCN, CNN, MLP. So it looks like if I just RMSC is an important criteria for sure. In that relation, GCN and MLP, I would say perform slightly better. This is 39.9. So GCN plus MLP came very close. But in other cases, will GCN plus MLP, let's say, it's probably some evenly divided. Okay, it looks like okay, it probably is hard to pick up. Now, if I see the second best and two of them is lowest, so probably that's why I put the GCN plus MLP might be it's slightly better, but overall GCN, CN, and MLP is very close and equivalent. And if I just only consider RMSC, then definitely GCN, CN, and MLP performs better in terms of higher epochs. In terms of ranking, I would say the paper, news, and then Kendall, Spearman, Pearson, right? That is the order. In my case, I still say causation, Spearman. And then I think from the figure, it looked like sometimes Kendall was better Pearson, but if I go here, if I count how many times they came, I believe Pearson might be better. So I put them as a tie. So in terms of challenges, yes, because I did not find the exact data set the paper is used, finding generating data that was a challenge, and also the exact architecture the paper has used, the details in the description. It was not clear to me, and then probably I did not see any code. So making my code similar to them was also a challenge. So more specificities would help. And the platform, probably a faster platform, and the platform the authors has used, it could help because I could do more experiment and more work and to get faster results. Then I could vary and get closer output to see which configuration works better. And definitely, as I told before, adapting data to different levels or different models, I think it seemed to be quite challenging. Now, because I have those challenges, definitely I have some limitations along this line in terms of my architecture is not exact and my results are not as perfect or not even better. So those are some limitations, but there are some promising thing there. We try, things can be improved. And another limitation is my data set is only 15,000 articles, but they had used 1 million. So yeah, ideally mine will not perform as great. And furthermore, definitely address these challenges, remove these limitations, and also address the exploding gradient problem that is comes with the GCN and ReLU. So that will be one area of improvement. Okay, these are my references, and then I hope that you enjoyed the presentations. So if you have any question, feel free to to ask, I'll happy to answer.